Yeah, hi, it's Keith. It gets comfortable. I'm going to talk about the LK range. Um, I'm not going to recite the specifications and the wonderful features of it, but I want to talk about more about its uses and benefits and why the LK range is so special. I was going to do this with a voiceover or some professional person because I'm probably not the right person. But anyway, I'm going to talk about the LK. Life's cool. I hope you like the name because I thought it was good anyway. So, you know, the LK range, and it was really born because CNI is becoming bigger and bigger. And, Sunsynk, we've been around for a while. And a lot of people probably don't realize that we've been involved in CNI for a long time. We have actually commercial systems. We've got tens of thousands of commercial systems around the world. And these things are operating everywhere, from hospitals. We've got systems in the NHS in the United Kingdom. We've got tens and tens of thousands of commercial systems across Africa, all functioning well, all running on our servers. And all basically what we've done is the CNI range is make it easier to use, improve, make it look good. But let's talk about it. Let me go through a simple presentation. And we'll start at the very beginning. Suppose you've ever looked at your electricity bill and wondered if you're funding somebody else's holiday home in the sun. People don't realize the cost of power, cost of energy. It's going up absolutely everywhere. Whether you're in the Far East, you're in Africa, you're in Europe, some countries is considerably more expensive than others. And I can tell you the prices in some parts of Europe are absolutely crazy, including the UK. And energy is increasing, and especially for businesses. And so, therefore, there are benefits having some sort of battery storage, because often you can buy electricity cheaper. But let's go through things and we'll talk about it. But first of all, for most of us, electricity used to be really simple. You basically there was no complicated things about it. You basically you actually subscribed, or you registered with your local provider, and they provide you electricity. And often most places are just a monopoly, just one or two, and you didn't really have a choice. And they provided you power, you paid your bill, and it was always a bit expensive, especially commercial, but it wasn't outrageous, and people managed the businesses well. But more recently, things are obviously getting complex. Electric vehicles, various tariffs, skyrocketing prices, problems with gas supply, lots and lots of things. And so this is why we've actually coming into the market with the LK range. We've been, as I said before, we've been at CNI for a long time, but we're now bringing in the LK, Life's Cool, which is a brand new concept. And I'll go through the concept with you. So, if you're starting with simple, people have to understand the differences. We've been making inverters for a long time. But when you actually compare the energy a house uses, so maybe typically a house, 5, 10, 15 kilowatt hour battery is perfect for a house. But if you go into a larger business or a factory or a warehouse, or basically many businesses and maybe a restaurant or whatever, then 15 kilowatts not really going to touch it at all. You need power. You need much, much more power. And this is really where it's all coming about. And the LK range is actually a whole range of products that start from 100 kilowatt hour to megawatt hours. And it all follows the same system. The LK range, we've got nothing, it's one system. And so therefore, if you get an understanding for our equipment, we're not going to change it. It's the same equipment in everything. That's very important, because people will buy one brand, another brand, different brand for the bigger, the smaller, whatever. But having one menu, as somebody says to me, is one product, and it just consists of a number of modules, and the whole thing, everything to do with the LK range, is a modular system. It all follows a limited number of modules, and based on these modules, we can absolutely build anything. So this is very, very important. Sunsynk, we've been making hybrid inverters for a long time. and maybe many people know us for our hybrid inverters. And so understanding the difference between a CNI system and a conventional. So I'm actually showing this on here. When you look at a sort of a small full hybrid inverter and look at a cabinet from a CNI unit, even though it's much bigger and has lots of components, they're principally the same thing. Inside a standard inverter, you will have things like your MPPTs, your trackers. They're the things that connect to the solar panel, and they convert your solar energy into a DC energy that you can charge onto your battery. You have your PCS, which is your inverter, it's a bidirectional inverter, so that can charge the battery and discharge the battery through the same thing. The PCS is part of a hybrid inverter, and even it's all in one unit, is basically all of these units miniaturized. You've got your energy management system. And yes, even the cheapest inverters have got an energy management system. It's the HMI, it's the LCD on the front, the UI. That's your energy management system. That's what's controlling everything. So you have your energy management systems there. And you've got your STS. So most standalone hybrids and all the ones that we produce all have built in an STS, static transfer switch, seamless transfer switch, whatever you want to call it. That's the device that allows it to work on and off grid. In most cases, you probably don't need to have an on-off grid solution, but it is nice to have that, and it is a huge benefit. So let us move forward and start looking more about it. But you can see on the drawing on the right here, I'm actually showing you the various components and what's in it, and they're actually the same thing. So basically, you need to understand you have all of these different components and within a cabinet, but they all run on the EMS, the energy management system. The energy management system that's in a CNI unit, be it a PowerHub or be it an Innagator, the EMS is designed to run the local system. So it's to run the unit locally. So basically, if you lose cloud or you haven't got cloud connection or anything, the system will work perfectly. It doesn't need to talk to a mothership. It doesn't need to actually talk to the cloud to commission it. And we know some other of our competitors may need to do that, but we feel it's very important not to. Coffee. So if you look at the drawing on the right-hand side, and then what I'm actually showing you here is how the HMI talks to everything. So you'll see on here, on the picture on the right-hand side, you'll see two battery packs. And each battery pack has their own, the BMS inside the battery pack. And the BMS will actually talk to the BMU, battery management unit. And that actually controls the charge. That's the master BMS. If you've got lots of packs, you need a master one. And the BMU will talk to the HMI or the EMS, and that controls the charge and discharge of the batteries. The other side you'll actually see is the EMS is actually talking to the MPPTs. They're the solar trackers. You don't necessarily have to have solar trackers, but if you've got solar trackers and you're going to use solar panels on your system, and we'll talk about that a little bit later, that unit has to talk to them because it has to regulate the charge going into the batteries. It also talks to the PCS, the power control system. That's the inverter. That's the thing charging and discharge. And it will also talk to the STS, the static transfer switch. And you'll see from this drawing, and you'll see the various components, and they are the components that make it up, but they are all talking locally to the EMS. But the EMS is actually connected to talk to the outside world, because a lot of people think, well, hold on a second, it's on my phone. Yes, it is. So the EMS, or the HMI, whatever you want to call it, connects to a router, a data router, similar to what you've got in the house. And then the router will connect to a data logger. Now, the data logger could be actually a Wi-Fi data logger, or it could be a cellular data logger. And the data logger, if it's a Wi-Fi, will talk to another Wi-Fi receiver, and it will send the data to the cloud. And then the cloud, we pick it up on the Sunsynk Connect, and we can see what's going on. And that's very important. But it's very important to understand what the actual HMI or the EMS is doing. The EMS in the Power Hub or Innagator is controlling everything. And we've got videos and explanation if you really want to start understanding it. But from a sales point of view, you don't really need to understand how you're going to program it because there's a lot in it. It does everything. It does absolutely everything. The best way I describe an EMS is like the heart. It's the heart of the system. And that's the way to look at it. It controls absolutely everything. And it's a simple way of explaining it. And that controls the system. It makes sure that your system is working and it's controlling. If you need to using the cooling systems, it will use them. If you need the heating systems, it will switch them on. If it needs ventilation, it will control that. But more importantly, it's controlling the rate of charge and the discharge, and of course, the demand. So you might have a pre-programmed demand. You might have it running automatically. So you might be looking at peak power shaving. You might be looking for it to do sort of export at certain times, import at certain times. That's all. That data is all held on the HMI, and the HMI can be updated. It can be programmed remotely, but in a lot of cases, it probably will be preset, and especially if you're using it in a factory, or if you're using it for boosting car charges. But you know, the thing with our system, it's simple. It's really, really simple. It's a really nice piece of kit. You decide, you know, what you want when you want to charge the batteries. When you want to discharge the batteries, think of it as a big reservoir, a big tank of water. That's what I always say. Electricity is always very like water. And you fill your tanks up when it's cheap, and when it's expensive, you either use it or you sell it again. You've got a choice. And it's a bit like, you know, I'm going to go, I'll use an example, beer. I do like beer, and you probably tell. And it's a bit like, you know, okay, right, I'm going to fill my tank full of beer. I'm going to buy it when it's really cheap because I can buy it so cheap for the beer this week. And then I realize next week, wow, it's gone up in price. Somebody wants to buy it off me. Well, they can buy all my beer they want. They can come on, they can fill you, you know, I'll sell it to you. And that's the same thing. Your electricity goes into it and sells again. And that could be a fully automated process. In some countries, like in Europe, we use the EPEX system. You might be using Octopus Agile. You might be using various different systems to do that. But that basically is a trading use. But obviously, it's got other uses as well. You may not be trading it; you might be just buying it, because sometimes electricity can jump up at certain times. You can have surges and spikes. You know, especially on commercial, especially if you're running, say, restaurant business, or you've got a high usage. And I've seen people having 3, 4, 5 time tariff meters, and maybe between 2 o'clock and 4 o'clock, electricity will rocket in price. Sometimes you'll have limits on what you can pull, and they might say, okay, well, you can pull, say, 50 kilowatts, but if you want 55 kilowatts, your whole bill will double. And this is just an example, and these are sort of dynamic pricing, and the electricity companies do this to discourage and say, well, you only take your 50, but if you pull more than that, even though your system can give you more than that, then they will massively penalize you. So one of the other things about all of the Sunsynk LK range, compared to some other products, we have the option to power it from the sun. So MPPT, which is your tracker. So you can buy the unit without solar, or you just want to use it for trading, you just want it for boosting, or whatever. But, you know, the sunshine, big ball of fire in the sky, it's free. Well, I'm going to say it's free because I do know in some countries they actually charge you for putting solar panels up. So they charge you for the use of it. I'm not going to say who, where, or whatever, but there are countries that actually charge you for a tax for solar panels that use the sun. Something to think about in the UK. I'm sure the government are looking to devise the tax. And I put it on a previous video, maybe they're looking for a sun tax to tax the sun. It's going to be an interesting thing. But the point is, if you want to have a system that can work off solar as well as a power hub, then you must choose MPPTs. You must say, right, okay, we want a power hub with, some people call them trackers, different things, but you must say, right, I want it to run off solar, or I don't want it to run off solar. You choose. That's the thing about it. These are modules, and when we supply the unit, it will be supplied with or without those modules, and it's a complete modular set. But it is important to understand that most of our systems can, if wanted, to run off the sun. If you are running off the sun, it could run just as a standard string inverter. So a conventional string inverter, where you have maybe a 50 kilowatt, 100 kilowatt string inverter. So you put your solar panels, and with a string inverter, which is an Americanism for set series, but everyone calls them as a grid-tied inverter. The sun is producing the energy on the solar panels. The solar panels then will go into the inverter, DC, and it will convert it to AC, and the AC power is exported straight to the grid. Or you use it. And if you're not using it, it might be on a school or whatever, and that power is exported, and it will give you 1 or 2 pence a kilowatt hour. The problem is, the sun shines, you export it, and when it's not shining, you're importing it at a much higher rate. And it's not a particularly, it's the original method. And I remember many years ago developing a grid-tied inverter, and I've got a video on YouTube, one of the very first one, actually trying to explain to people what an inverter was. It was a long, long time ago. But this can operate as a standard string inverter. The other interesting thing, if you really wanted to, it can operate even without the battery. But we're talking about function now. We're talking about standard PowerHub and standard Innagators, and these all have batteries, because the most important thing is, rather than exporting straight out, which you can do, but you can put that energy into the batteries, fill your boots up, and use it when the sun is not shining or when it's expensive. But the beauty of solar, it's free in most countries, it's free. And so consider, when you're looking at PowerHubs, consider to look at it with solar option. And all of the Sunsynk ones have solar, and that's the beauty of it. So I make a big point. It's the MPPT, it's the tracker, with or without solar. You have to decide. But with solar, you've got free power. If you don't need solar, then there's no point in buying it. The other thing is, if you choose not to have solar, you can upgrade it later. You can say, well, hold on, we need to buy the trackers now. And you know what? They just simply slot into the case, and it's as simple as that. So, power in practice, and we're looking at these PowerHubs. They're good looking, aren't they? One of the things, it is plug, play. Wiring, if you say, right, okay, I need it on a commando plug. Yeah, we could do it on a commando plug. Absolutely. If you want it just to plug in, it's a simple plug-in. If you're going to be using it on a remote site or a work site, and you need that unit to be plugged in, then we can put the commando socket on it, and you can plug, play, whatever, it'll work. But they're simple to wire, especially if you're going to be using a standard grid type unit. It's only got one electrical connection, a single electrical connection. That's it. That electrical connection could be an input and output. If you got no solar panels on it, it's just one connection. One connection. It's as simple as that. A 3-wire connection. If you want to use it if you want it for other uses, for example, if you want to on a film crew or something like that, then you may want to have the stability, and you want the UPS function. Because you haven't got mains, you might be charging it remotely and bring these things and bolt them on the top of a lorry, and they turn up, and you've got your energy for your site. Sure, you'll want sort of, they call them commando plugs, and that will give you an output, and that will give you a UPS output, uninterruptible power supply, or an off-grid output. But you choose. This is the thing about the LK range. It's all a modular, and you choose what you want to do. And it's very important to understand how it configures, because the simplicity of its configuration, the simplicity of its servicing makes it special. So it's really simple to understand. And I've done 2 simple drawings here, and you can actually see, using a grid tied, which most of the systems will be grid tied, they'll be on-grid systems, and rather than hybrid systems, because you're not really using it for backup power, unless it's a backup power, but most of them just connect straight to the grid. So you've got an inverter, you've got your limiter, and you've got your battery. And so basically, you can see from this simple line drawing, the power can go either way. It's like a reservoir. It's like a big tank of water. And as I mentioned before, it could be a big tank of beer. And it's very simple. The energy flows from the grid into the inverters, the battery, and backwards. The grid itself is connected directly to the load. We actually call that sort of configuration AC coupled, and it's because you only use one wire. And you can see from the video where I'm actually showing a real product, you can see this installation is extremely simple to do, and that's why we use most of the systems that we'll ever offer are on-grid systems, pretty much like the old-fashioned string inverters. But if you look at the image, on the right-hand side here, you see I've added the MPPTs, the power trackers. And basically, the solar panels connect to the MPPT connects to the inverter, and the inverter connects to the grid, very much like a standard string inverter. And that can export if you want, or it can store the battery it can store the energy into the battery. So you've got a choice, and you can program it. So generally, it functions exactly the same as a standard string inverter. No difference. It will wire the same as a standard string inverter. So if it's a 50 kilowatt or 100 kilowatt inverter, just imagine it's a 50 or 100 kilowatt string inverter. But it gives you the benefit of battery. Now, if you said, right, okay, well, I want to save money at the moment, so don't want to put batteries yet, we can do that without battery if you wanted to. But generally, you're better off just having the whole thing finished and use it with a battery. But it'll function exactly that way. So if you're going to do your rate of return, it's much better, because when you consider a normal just string inverter and the sun is shining, it exports everything away and you've got no real benefit. The benefit of using a storage system, like anything in the LK range, you choose when you wanted to divert it to the battery and export it. And it's only a single connection. It's really, really simple. And because, we're using sort of dynamic air cooling system, it's very, very low. It's very low cost to run. Your rate of return is really, really, it's an absolute no-brainer. It's really positive. It's very easy, and it could definitely make you money. And I'm rabbiting on too much, so tell me to shut up. And you can put in the comments, please don't rabbit on so much, because I love it. I absolutely love the product.
Right, okay. Let me show you the difference. It's really noisy area, but understanding the difference between off-grid, hybrid, and on-grid. This is an on-grid power hub. This is a 215 kilowatt on-grid. So of course it's much cheaper. You see here we've got 100 kilowatt of PCS, and you look at here, the electrical connection, it's very simple. You haven't got the complicated electronics. You haven't got an STS. You haven't got a lot of the stuff is missing, because this is used for grid stabilization, or basically for grid trading. So it's a very simple system. You've got your 215 kilowatt battery. You've got your mains breaker here. You've obviously got all your protection stuff. You've got your EMS energy management system here, but the system itself is much simpler. And you can compare this one as being an on-grid system and compared to what I've just showed you and explained about an off-grid system. They're very different beasties. And some people looking at our pricing say, oh my God, you're more expensive. But they're comparing with an on-grid to an off-grid. Of course, there's a huge price difference. So this is a very nice, it's a much simpler product. You see here, the connections are simple. It's got the it can have the transformer or no transformer, but it's a very, very simple product. So this is why I'm demonstrating the difference between an on-grid system and an off-grid system. And so you can see it's still got the HVAC system, it's still got the cooling, forced air cooling. I love forced air cooling. Yeah, I know everyone knows me, but I'm a real fan of forced air cooling. Because, in a lot of Europe, you don't really need cooling, especially in the UK, because it's always cold and raining, a bit like Hong Kong. So this is it. Look at the difference, understand it, but from a wiring point of view, all you've got here is your three-phase connections, three-phase neutral air, wiring to it. You have two configurations. If you're wiring in certain countries, like the Philippines, you may be on a Delta grid, you haven't got a neutral. For the UK or South Africa, you're a star grid, and so you have a neutral. And that's it. It's as simple as that. And this unit here is actually running, it's working, it's functioning. Okay, thank you.
PowerHubs, sort of PowerHubs work in the same way as our larger LK systems, and they can cascade, they can parallel. You don't need, if you're paralleling and you're on grid, then they parallel. The grid synchronizes it. The grid will always synchronize it. So if you're going to parallel, you can put 1 on, 10 on, 20 on. You don't need to, when you connect them together, you connect them onto our Sunsynk Connect, and that will accumulate the figure. So you see the gross figure and the net figure, what it's all producing, what it's doing, and you can control them all together. However, they are independent units and they will parallel. The only time you start considering when you're paralleling is if you want to parallel off-grid. And so therefore, if you want an off-grid solution, of course you can parallel so many, but honestly, I think if you're running off-grid, you would do the configuration differently. On-grid is is really, really simple. And if you're using PowerHubs, 3 wires, or 4 wires, depending on your configuration and the grid code compliance, whether it's 3 wires or 4 wires. I'll talk about that in a second, the different types of configuration. But they're parallel. And you can mix and match. You could actually have some PowerHubs, you can have some indicators, you can build it up. You can mix and match the system. Of course, if you want UPSs, you wouldn't parallel all the UPSs because your cabling is going to be so thick. Your grid is paralleled. You've got no choice, and that's how it's wired. The grid, whether you're connected with your farm and next door's farm, you're on the same grid. You're on the same grid. It's connected together. But your output, you wouldn't parallel that. You would output that. You set your fuse boards and you would balance your systems, and that would be done a little bit differently. And if you want help on that, I'm sure our people can help on it. But certainly for the vast majority of uses, and I probably say 90% of the uses, these things are just going to be grid tied, paralleled, and that will give you grid stability. It will give you, if you want to use frequency stability, whatever, grid trading. They just parallel 3 connections in and out. Just think of they're like a water tank. It's a water, and the pump can fill it in and empty it. It's just got one connection, one single connection. It is simple, simple, simple as that. One of the things about it is these things are pre-wired. When you install it, they're actually pre-wired. They're all done. All the work's done, and that's very, very important. These things are built for the British weather. And I'm sitting here recording this video, and the weather's horrible. It's raining, raining, raining. Everywhere I go, I was in the Philippines. We were presenting in the Philippines. I don't know. In Hong Kong people say, well, it's lucky. Rain is money. Is like, they consider it lucky. Well, sometimes I think, well, maybe it shouldn't rain so much. Maybe, I don't know. Maybe I'm just unlucky with the weather. I don't know. I go out those places, but we are in the UK and it's pretty horrible. But these things, British engineering for British weather, they're robust. They're not designed for sort of nice weather. Anyway, let's move on. So we're always looking these things, the sort of PowerHubs. They should be actually, we want the things to be good looking, and this is what it's all about: making it look good as well as it functions good. And in the real world, they've got to be strong, tough, and robust. But there's lots and lots of things. Let's look at the LK. Let's look at the Innagator. And you can see on here the drawing we've got on the sort of left hand side of the page, we've got a complete Innagator here, and you can actually see you've got 2 cabinets. One cabinet on this particular one contains the PCS, power control system, the inverter, and the other cabinet next to it contains the trackers, the MPPT for the solar. And that's really important to understand that, because these are all pre-wired together, but you basically wire your solar panels. You connect your solar panels to the MPPT tracker, and then you connect your AC cables to your batteries. And you might have solar on the system, so you just only have 1 cabinet. But if you've got solar, you've got 2 cabinets. And on this one, this is a 1 megawatt unit. You can see the battery packs on the right-hand side, and there's actually 4 battery packs. And these battery packs are your 1 megawatt, the 250 kilowatt per pack, and you can see them there. And what I'm actually showing on the right hand side is I'm showing if you open the cabinets up, and you'll see inside the cabinets, you'll see the modules, and these are the same modules that's used on everything. We just on a PowerHub, there's less of them. On an Innagator, there's more of them because it's bigger power, and that's it. They're all the same module. Everything can slot in, can slot out. That's important. And I'll talk about that a bit further on into the presentation. But everything is all in there. And the nice thing about it, when we put a container together, you could actually say, well, okay, well, we can sell you if you wanted to. We could sell you the MPPT cabinet. We can sell you the PCS cabinet. We can sell you the battery packs. You put it into your own container, or you can buy one. All this is basically the container has the HVAC, the cooling systems in there, and it has a few other systems. Obviously, the safety systems, the venting systems, some lighting. If you open up so you can see what's going on, it's got fire detection systems. There's other systems in there. And we also include a certificate for the whole product. So this is how it operates. But you can see on there, you can see the cabinets and the very, very simple cabinets. And you can see how it all goes together. Right, I hope I'm not boring you so far. We're about halfway through this training video. I'm going to move on. I'm just going to talk about UPS. And so far, I've been talking about everything has been on-grid. But I'm going to talk about off-grid, which is UPS solutions. So I think I'd like to show you a video. I'm going to share with you a video of a PowerHub, which is a UPS type. And then you can see how it functions. So watch this. So I hope you enjoy the video.
We're rock and rolling. Okay, promise we start doing some more of the training videos for the PCS PowerHub LK range, our range. So let me explain. We're actually in the production area, and it's better to show you this one because it's partly dismantled and explain what the various components are and what we can do. So of course here, this is a 215 kilowatt hour. We have 250 kilowatt hour units. They've got air blowers onto each of the batteries. We've got the HVAC unit sitting into the door, and you can see the airflow, how the airflow operates. It works a treat, absolutely no issues. But let's focus more on the unit itself. So on the bottom here, on the PowerHub, you've got 4 channels. They are your MPPT inputs. They've all got separate DC isolators for the solar isolators as per the standard requirements. On top of that, this is actually a generator. This is the override switch, which basically connects the load and the grid together. If you have an issue or you want a maintenance issue or you need to shut down, you can click the switch over and it gives you a complete override. It's a very, very nice feature. So on here, you've got 3 breakers. Now, the configuration on this is slightly different, so we're going to change the configuration. At the moment, you have grid input, you have load input, and this one is actually generator input, but this is direct connection. You have to physically switch, you have to override it. It's done by a breaker. What we're intending to do is connect this unit here to, on the top here, we're going to fit in an additional PCS. So the generator port connects directly to a secondary PCS that connects directly to the DC bus. Why would we do that? Simple. That means if that generator runs, and the generator is running at, say, 45 or 48 hertz, or the frequency is unstable, it will still charge the batteries. And amazingly, you can run the grid and the generator be at different frequencies at the same time. The rest of the thing, this is your MPPT module. We have space to add additional MPPT module if you want to. This has got 100 kilowatt. These are 50 kilowatt each, and this particular unit has 100 kilowatt MPPT, which is split into 4 channels. Here, which hasn't been installed yet, is actually the PCS, the Power Control System module, and that slots in here. And here is we've got the STS. The whole thing is actually connected to a transformer. Come and have a look around the back. So here, you see here the guy's working on the transformer, and this is the transformer. It's transformer coupled. It's amazing, isn't it? This is a real beast. We have a transformer coupling for the AC. You can run off grid. It can run on grid. It can run a generator at the same time. Generator running at the same time as grid for a load sheet. It has a lot of beauty features. You've got the HMI, or you've got the EMS. This controls the local EMS. So this EMS controls the system EMS, and it allows the PCS, and it allows the MPPT, and it allows the STS to work as a hybrid inverter. We've got some videos showing how this thing operates. I'll show you as a separate video. So how it's actually functioning. And here you just local supply, local breakers. You've obviously got your fire detection system, your various sensing systems, lots and lots of things going on here. So this one is actually in assembly, and I just thought it's nice to actually demonstrate and how the thing assembles rather than showing there's a finished product. So this is being assembled, it's being completed, but this is one nice piece of kit. It's absolutely unique, and nobody else actually has this feature. So I'm going to go show some separate videos on how or what the benefit, what PCS is, the power control system, what an MPPT is. I'm sure everyone knows what an MPPT is, and I'm sure a lot of people know what STS is. We call it seamless transfer switch or static transfer switch, whatever you want to call it. Some people have slightly different names, but it doesn't matter. I'm probably going to get loads of comments about that. But you know what? There are lots of these things hitting the market. There are two types. So this is an off-grid. This is a full hybrid system. This is giving you for full hybrid. And we did a demonstration, which I will add to this video, where we're talking about the EMS and we're showing the changeover, and it's almost zero changeover. Almost zero changeover. It does, and I've got a demonstration showing it actually operating in our Hong Kong office, and it shows the function. So there's a lot going on. This is a real product. You know, people worry about, say, oh, how am I going to use a PCS? How am I going to use the various components? Don't worry about it. They are a little bit complicated to use, and so we're building up standard units, standard pieces of kit. It's got the various communications, so you don't need to worry about all of that side of it. These are built-up units, and these are an amazing price, absolutely amazing. This piece of kit is better than anything else on the market. Anything else. Can your generator run the same time as a grid? Can you use any generator with it? You can't, because I've never seen one that does these features. This is, I'm sure in 6 months' time, after people see my video, lots of people think, oh, well, that's a good idea. Well, you know what, Sunsynk, we're trying to do it first. We're trying to produce the best product on the market. This is one hell of a piece of product. We're not going to give any sexy videos or whatever. This is hardcore, absolutely built for the rugged. This is hardcore product, built to last. So listen, thanks for following us, and more videos coming. Cheers.
On-grid and off-grid solutions are very different. On-grid solution, and in fact, pure off-grid is the same. So pure on-grid and pure off-grid is the same unit. They're really least expensive because you don't need to use static transfer switches and you need the least amount of equipment. But having units that are both off and on-grid, especially on the bigger stuff, costs a little bit more. It's not stupidly expensive, but it costs a little bit more money, and they are different. So if you're actually looking to using for a data center or for a school where you need power all the time, or a hospital, or if you're in an area of the world where power is a problem, many areas of the world have got intermittent power. We do work in Pakistan, for example. They have issues with intermittent power. Philippines have issues with intermittent power. South Africa did, and I think at the moment they got load shedding. I think load shedding at the moment is temporarily low at the moment, but it will come back, I'm sure. Likewise, they should do what they do in the UK. They just put the price up so high that people can't afford the electricity, so they switch things off themselves. Different mentality. But anyway, it's all the same. It all results exactly the same thing. But looking at, looking at where you would use that and understanding the differences, that was fundamental. That's why I tried to share that video. But how does it work? So on the right-hand side, I'm actually showing you how the actual units work. So the solar connects to the MPPT, the tracker, maximum peak power tracker. It's just a device. It's basically a DC to DC converter, and the solar panels connect to that. They then charge the batteries, and it's actually charged by the BMU. And the drawing doesn't quite show, but the energy will actually go through the BMU, the battery management unit. It will charge the batteries, and then the batteries will eventually discharge through the BMU, or discharge whatever you want into the PCS. And the PCS is a bi-directional unit, and then the PCS connects to the AC bus. That AC bus is giving an output or an input all of the time, depending on what the inverter is doing. Then that connects to the STS, the seamless transfer switch, where you've got the grid and the load is connected to there. The grid and the load are in parallel. They're exactly the same. So that's how it functions. Now, one of the things you've got to realize is if you're working off grid and then you've got grid present, the two of them have to synchronize. You have to synchronize the frequencies. Otherwise, it won't work. And that's why there's always a delay. So when you first start up, there's a delay, and it's allowing. You can't change the grid. The grid can't move. That's all. The frequencies are always the same on the grid, but the inverter will move a little bit until the two frequencies lock in, and the frequencies are locked in. And once they are locked in, then the STS can join the grid onto the AC bus bar, and then that can be used to charge the batteries or discharge the batteries or whatever you want. And the grid side itself, the discharge or the charge is controlled by, normally on smaller inverters, we use a CT coil, but the bigger stuff, we use a meter. And the meter will actually tell if there's export happening or if there's import happening, and that will tell the inverter to increase the voltage slightly or lower the voltage slightly. So when you increase the voltage very slightly, it will allow a flow from the PCS into the grid. When you decrease the voltage very slightly, then it will allow an import. Or if you keep it equal, then nothing happens. That's how it controls it. So the voltage is either slightly up, slightly low, slightly lower, or exactly the same. And that actually controls the import export to the grid from the PCS via the STS. Simple, isn't it? And these are now, when you look at an all-in-one inverter, you don't see any of these parts, and it's exactly the same on all inverters. Except when you're looking at big CNI, these are big units, great big units, rather than all built in this one compact unit, one compact item. So the miniaturization, and basically that's the biggest thing about the hybrid inverters, the miniaturization of where you had lots and lots of separate units. But of course, things are becoming more powerful, things are moving on. But just to understand that, and that's really important. Let's move on. Reliability. You know, this is critical. This is absolutely critical. You know, reliability, and serviceability. You know, a long time ago, you know, people used to joke, and everyone knows that I live in Hong Kong. And many years ago, first go to Hong Kong, used to say, "How long is your warranty?" And the shop guy would say, "We're going to buy." I remember buying a camera when people used to buy cameras, and you look at it, "Oh yeah." And how long's the warranty? Oh, whatever, 5 years. Well, actually, the truth was the warranty lasted until you step foot outside that shop. Once you step foot outside that shop, the warranty's finished. And sometimes even before you left the shop, the warranty had finished. You try sending something back, it's impossible. And that can go with a lot of things. So just reliability is so important. It's different for Sunsynk because we're on the ground. We've been going a long time. We're not just another nameless company. We are with people. We try to do things. We try to do things right. And people, we had, some things are not always perfect like everybody, but we do try our best. We really try. And, but reliability, we spend a lot of time making sure things are reliable. And one of the things that we do is all of our units are tested. And be it whether you're buying a small inverter or you're buying a large CNI system, it's tested before it leaves the factory. It's fully tested. One thing I always will say, though, if you put a large system on a site, and be it a PowerHub or an Innagator, you must do a local electrical safety test because things move and they move in transit. And I would always say, and if you know me, I'm an electrician, electrical engineer, time served, full apprenticeship, and that's my background. And I would always say to people, you must actually test it and do basic testing. It's just safety. And that testing should be repeated once a year. So it is very important to do that. But the most important thing is to understand what we ship out as Sunsynk is tested. It is tested in the factory, and I tell you what, I'm going to share a short video with you, part of another video. And you can see the guys working on something because people, again, it's all faceless and they don't realize what goes on. But, we've been making these units for a while and we're making these big factories and stuff. Let me share with this short video and you can see about the testing.
So this is just the environmental testing. This is the PowerHub during environmental testing for low, high temperatures. General sort of operation tests that we do within the factory before we release the goods into the market. Thoroughly tested.
Okay, let's move on. Charging from a generator. Yes, this is an absolutely must in many countries, especially if you're working off-grid or maybe even on-grid or maybe hybrid. You want to use a generator. If you're going to use it on a work site or maybe a film crew, you need to be able to hook it to a generator because the generator, you don't want the generator running all the time. And nowadays, in many countries, it is law that you have to have a battery pack with a generator on a work site for over a certain size. You can't just run a generator 24/7 because you're just wasting fuel. Generators, a lot of time, you got these huge generators chugging away. and nothing being used. You might be running at nighttime and have so many lights, or you might have the demand, or you might have a demand, or you might however it does. But generators have optimal running power, and in reality, you may only need to run the generator once a day for 1 hour, but the power hub or the Innagator can supply you energy all day. So if you're taking it to a work site or a film crew or anything like that, it's very, very important to be able to charge it from a generator. So I was trying to explain there's two ways to charge these things. And if you watch the previous video, we sort of explained it. But charging it can be difficult, because normally when you're using a generator on a power hub or something, the generator actually has to charge it charges the battery, but an inverter can only work in one direction. So it can either charge or it can discharge. Now that gives a problem, because if it's you wanting to charge the battery up, you have to use that generator to charge the battery up. But because the inverter component is being used to charge the battery, they can't discharge at the same time. So the generator has to be powerful enough to take the whole load and charge the battery at the same time. So roughly you may need to generate twice the capacity. So if you've got, say, a load of, say, 50 kVA, then you may need a 100 kVA generator, big generator. And that scales up. If you're talking, say, 500 kVA, you need a 1 megawatt generator to charge and take the load at the same time, because if you're trying to recharge the batteries, because if the batteries are at C2, then that means it will take 2 hours to charge it, which will draw 250 kVA. The load is 500 kVA, and so it's 750. You get a little bit of tolerance, would be a 1 megawatt. So that's the problem. However, Sunsynk has an alternative solution. You have two solutions. One, you can using the ATS and you can charge it in the conventional manner, for sure, that can work. The second solution is we add a second PCS, power control system. And the second PCS is directly connected to the battery. And if you see the diagram on the right-hand side, you'll see the MPPTs join the battery. And the battery through the BMU goes to the PCS goes to the AC bus, and it goes into the STS like before. However, we have an auxiliary, a second PCS, a second inverter. And that secondary inverter will charge the batteries directly from the generator. What's the benefit? Well, the benefit is, one, the generator doesn't have to hold the full load if it's ups and downs, because the inverter can be just discharging the whole time. It's not going into charge mode. It's only into discharge mode. The generator is directly inputting onto the DC side of the of the power hub on the battery. So it's directly into the DC side. That means if the frequency is up and down, it doesn't matter, because that PCS will lock into that generator, because it has to lock. And the generator will, you choose how much power you want it to run, and whatever the generator has the capability, you match that secondary PCS to match it, and that will directly charge the battery. Because as I mentioned before, the frequencies have to match. You know, the AC is going up and down, and you've got the system is maybe operating, or it's linked to the grid. So when it's linked to the grid and you add a generator, that gives a problem. So if you're running off the grid and you want to use a generator, you can't. It's very difficult, because the frequency of the generator has to match the frequency of the grid. That's impossible. It's really, really impossible unless you're using a mega, mega expensive generator set. The other problem is the generator. If you're using it with a generator, it will take the whole load and it will connect. So basically, if you haven't got grid and you want the generator to come in and start charging the batteries, then the generator has to supply the whole load and charge the same batteries at the same time. So you probably need you will need a double the size generator, because it has to supply the load and charge the batteries. By using a secondary PCS, it doesn't. It directly connects to the DC line. And so if your load is fluctuating, when your load drops a little bit, then it will be charging the batteries. If your load increases more, then it will discharge the batteries, but it's putting energy back into the batteries directly. It's actually DC coupling. So you have an AC in and it's DC coupling. That's called DC coupling. And it's a mega, mega, mega advantage. And that's what makes the Sunsynk PowerHubs and Innagators Very, very special. And if you specify you want an auxiliary PCS, specify the size. Normally it's a 50. If you say I want 100 or a 125 or a larger one, depending on the size of generator you use, we can install larger ones for you. But having the use of an additional PCS, it makes a huge difference, and it allows that flexibility. And if your generator is out of frequency on the auxiliary, we can set it as an out of frequency PCS, so it'll compensate a little bit. It doesn't need to. You don't have to lock everything in together. There's no locking of it, because the other problem is often when a generator starts and then you put the load on because it's going to take the whole load, and suddenly the generator and then the frequency moves up and the system will kick it off. I've seen it on boats. A big problem, a huge problem, because generators suddenly, when the generator gets a load, it will slow it down and the frequency will suddenly become 49, 48, 47 hertz, if we're running a 50 hertz system. So that's so important. But having the auxiliary PCS, power control, having an auxiliary one, the generator can connect straight to it. That's what makes it special. And that is a major, major, major selling point of our product. And it makes it much better than anything else on the market. So when you specify, when you order it, always consider, if I'm going to use a generator, suggest buying an auxiliary PCS. The cost is hardly anything. It's much more stable. You don't have to switch as clunks. You've got no power outage. It's continuous power, continuous. And you can also consider other options, because if you're, for example, you need for a data center, you want continuous power, you could connect the grid to the auxiliary PCS and pull your power off the main one. And that means you've got an inverter, a battery, an inverter. It's continuous power. There's no changeover. And it's not like one of these, because, on an inverter, the AC bus is common. So when you go from when the inverter is moving from one state to the other, there's no changeover, because there's no changeover relays. But if, for example, then if your inverter is in discharge mode and you lose grid, then and you're on a UPS, there's no changeover, because it's still continually feeding. There's no changeover. It's not like the old-fashioned type of inverters. But if the inverter is in charge mode, you've got the inverter's got to turn state, and so there is a very, very short changeover. It's milliseconds, but you have got a physical changeover. You will get a very, very slight click or glitch or whatever. You probably won't even notice it, but it does exist, and some sensitive equipment can affect. By using the PCS, the secondary PCS on an AC, then you've got no. It's absolutely amazing, and that's built in. That's the option. So if you want, when you choose a PowerHub or an Innagator, you can have that as an option. Do you want a secondary PCS? Typically, the secondary PCS on a PowerHub is set at 50 kVA, similar to the Innagator. If you need bigger, then you need to specify. And we say, right, okay, but we need a larger, we want to directly port a generator onto it, and we need to use this size. We would like to use a 50 or 100 kVA genset. And so when you specify the model you want, you must specify, I want a secondary PCS. Otherwise, it doesn't come with it, because we're not going to put things that are going to cost money. However, it's nice. It's really, really, really nice feature, and it's something to consider. And especially for many applications, and it's beautiful if you're running on to say a work site or a film. Filming, the last thing you want to film is even if it's just that you don't want it, because you pick up on your sound system, maybe, I don't know, you don't want it, you just do not want it. So use Sunsynk. Consider Sunsynk product. It's really, really good. Not many people do this, and this is quite special. And to understand how a secondary PCS can be such a benefit to using the system. So let's move on. Grid code compliance. That's a big word. Yes. Well, grid code compliance means that the unit, the inverter, must match the legal requirements and the infrastructure requirements of the country where it's being used. There are some complicated things to do with grid code compliance, and there are some easy things to do with grid code compliance. One thing you must be aware is that many countries, well, not many, but some countries, the grid is configured in what they call a delta format. So it means it's got 3 connections, L1, L2, L3. There's no neutral. Norway, for example, is Delta Grid. Also in Philippines is also Delta Grid. And I didn't even know that. I learned that recently. They don't use a neutral. Their voltages are different than the EU, but they don't use a neutral. Electricity, the way it's generated, you know, from when it was first the generator from Mr. Tesla invented the first AC generator. One clever guy. I absolutely admire Mr. Tesla. He was an incredible genius. But one of the things is the generator turns around, it energizes each of the coils, and it's generally produced into a delta format. For example, in the UK, we put the delta into a transformer, and it becomes a star, which we use for the power transmission. The center of the star, which is the neutral, also is the earth connection, and we put ground rods and we do an earth neutral bond at the power station. And used to many places, like in South Africa and locally, they've got earth neutral bonds. It's not always that common everywhere because it affects RCDs and stuff. But to understand there's a difference, Delta Grid and Star Grid. If you're using standalone inverters rather than a complete power hub, then it makes a difference on the voltages, the battery voltages. It does actually make a difference. So if you're using a Star Grid or a Y grid, then the voltage needs to be a little bit higher than a Delta Grid. But as far as when you're dealing with indicators or power hub, you have to specify the usage. Is it going, and that would be the country. So again, this is another thing that we need to understand. Is it being connected to a Star Grid? Is it being connected to a Delta Grid? Very, very important, because otherwise it can't work. It won't work properly. All the voltages are wrong, because on a Y grid or a Star Grid, the voltage between neutral and L1, L2, L3 is maybe 220, 240 volts. The voltage across L1, L2, 3 is 440 volts. On a Delta Grid, it could be the voltage across L1, L2, L3 could be 260 volts. So the voltages are different. So that's the next thing you need to do, is confirm what voltage it is and what frequency it is, because the Philippines is 60 hertz, USA is 60 hertz, the UK is 50 hertz, or Europe is 50 hertz. So you need to confirm that. Now, besides those, they're the simple things to know. But the rest of the grid code compliance, once we know the country it's going into, then we can pre-configure the product, the inverter, the Innagator, the power hub for that country. So if you say, okay, we're going to install it to Germany, we're going to install it in the UK, we're going to install it, they have different other parts, which is the grid code compliant, which is even more complicated, to do with ride-throughs, to do with harmonics, to do with lots and lots and lots of things. I think a lot of the cases, you need to specify what it's being used for, because the unit can be connected to a nice smooth linear load, which is unusual, or it could be a very high reactive load. Reactive is motors, anything coils is a reactive. You tend to be, in nowadays lighting, and it's all corrected, so electronics is quite linear lighting. But if you're going to put it to massive machines or transformers and stuff, which is very reactive, so reactive causes a power factor to shift. If you're going onto an inductive load, so on an inductive load, it will give you a 90-degree shift in the power factor. And if you're going onto a capacitive load, it will give you a 90-degree lead on the power factor. It's important to know that, because the unit itself has to do that correction. But it's a good guide. It will do it automatically. So it's less important, but you should also state what it's being used for, what the country is, and to understand the basics. And this is all to do with the grid code compliance, and they're all different. Every country is different. But if you're selling the product, don't worry too much about it. Honestly speaking, we will include a form, fill the form into the best of your ability. If there's questions, but that's quite important to understand that. And I think also we're trying to understand the sort of charge rates, discharge, other stuff, which is non-grid code compliance. But grid code compliance is the legal side that has to do to physically match with the grid, and to make sure the unit will actually work. Otherwise, you're going to get a product there on site. You're going to plug it in and it's going to blow up, or somebody's going to turn up from the district, from the electrical company, and not be very happy with you. So something to understand. Move on. Parasitic loss sounds like a disease. This is something people don't actually realize. And this is really, really, really important. Really important. Because it's all about, a lot of the time when you're going to use these things, if you're using it because you have to use it, is different. But if you're using a PowerHub or an Innagator to make money, then you must look at the parasitic loss. We call it maybe quiescent power, whatever. This is the idling power. There's lots and lots of words you can use for it. This is the energy the unit uses when there's nothing connected to it, when it's idle, and because it's chugging away. It's not generating power, it's not outputting, but it will use energy. So if you've got, for example, if you've got a water or a liquid cooled system, that pump may be running 24/7. Maybe you have to run all the time, because if you've got very super high density batteries, and then you're having to run the cooling system continuously, and that's will cause you a parasitic loss. If that is the case, then you need to look at that figure and you need to ask your supplier. And whether it's Sunsynk is different, because we focus on super efficiencies. But not everyone's the same. Not everything is in the box. And I'll give you an example. I'm showing you one here, which is I've given an example of 2,200 watts, which is a parasitic loss. And I saw a pretty small system in Hong Kong, manufactured by a company, and it was about 7,500 watts parasitic loss. So it's, you do your math, and this is a 24/7. And some of these things have to have a generator just to cover the parasitic losses. So basically, this is the energy it's losing. And if it's losing something like 2.2 kilowatt, it's 2.2 kilowatt, 24 hours a day, 7 days a week, every month, all a year. So a small parasitic loss, something like 2.2 kilowatt, is something like almost 6,000 a year. Oh, it's a lot of money. And I'm actually looking at pounds there, because in the UK they're about 30p a kilowatt hour. Okay, countries different rates, and it could be 30 cents, but in the UK that's the cost. It's very expensive. We try to keep, many of the Sunsynk systems are as low as 150 watts, quiescent power, but they're very low. They're much lower. But we're trying to keep these things as low as possible. And that makes a huge difference on your payback, on your rate of return. It's massive, massive, massive. So you need to look at this. And one of the major reasons about having such a low parasitic loss is our cooling method. You need to look at how the system is cooled. We actually, because we use low density serviceability batteries, we don't actually, our batteries are not plumbed in. We don't have water. I know maybe people don't always agree with me or disagree with me, but one of the things about not having to pump water or liquid through the unit all of the time is you're saving a massive, massive amount on energy. So if you choose to use high density batteries and you're having to do cooling systems in it, which got to run 24/7, one of the things to think about is how much energy is that system drawing? What's the energy? Whereas, for example, in a moderate climate like the UK, a lot of the time you do not even need to run any sort of cooling system because it doesn't need it. So using sort of a air-cooled super low density battery system, 90%, 99% maybe, depending on the weather, it's not running at all. And you're not wasting that immense amount of energy. So please always look, whatever system you choose, look at the parasitic losses or the quiescent or the idling power, what it's drawing when it's not running, because you'll be surprised how much energy you're actually losing. But one thing, if you use a Sunsynk, be confident our power is low. We are absolutely one of the lowest rated. So that's very important. It's really, really important. There are other companies do similar, but we boast and we pride ourselves using the method of cooling, which is different to a lot of people. Not completely different, but we are a little bit different, and it's very, very important. So always, always, always look at your parasitic losses, because that's very, very important. I'm going on, and I'm going to give you a couple of examples of systems where you can use it. I think that's important. So I'm not going to go hundreds and hundreds and hundreds of examples, but we're talking about money, energy is increasing. Some people say sort of snakes and ladders, it's up and down, or whatever. More often it's up than it is down, but it's something to consider. So I've got on here just two examples of where we use it. I've got on here just two examples of perfect uses for a power hub or an indicator. One is car dealerships. There are how many car dealerships around the world? Well, guess what? All cars will become electric eventually. Whether you're a petrol head, and I have to admit it, I love the sound of a V8, and I love hearing big engines. I like see. I only watch it TV. I never been fortunate enough to see it live, but you see this also Grand Prix and the roar of the engines and everything. I did see one time they had the E-Prix in Hong Kong, and they were whizzing around at 200 miles an hour, and all you go, that was it. It was great when you see there's that. So I love that. But guess what? All cars globally will all eventually become electric. It has to be. I'm going to show you an example, where it's a perfect example where you would be using a power hub to charge as a charger. It could be anywhere. Watch this short video, and I think you'll like it.
Hi, it's Keith. Wow, look at the weather. It's beautiful. I was actually away with my parents last week, and we were at a large hotel in the United Kingdom, and there must have been 1,000 cars in the car park, and there's only 2 EV chargers. And I thought, this is ridiculous. There should be at least 20 or 50 EV chargers. There wasn't any. And I actually asked them, because I was fortunate, one of the energy people was wandering around the hotel, and I asked them, I said, how come we've only got 2 chargers? They said, well, we're not allowed more than that because the grid, we can't put more than that, we need more. And and I'm thinking, well, this is crazy. But look at this. This is obviously familiar with our power hub. I've done lots and lots of videos of the power hub, and I'm going to wire an EV charger to this. We're going to put a DC, a 30 kilowatt DC EV charger on the end of this. We can use to charge it, and it sits nicely under this. Look at this. We're in the UK. Look at the weather. It's beautiful. We're going to wire underneath this. So we're using the solar array, this carport solar array. We're going to wire it to the power hub and the EV charger. And guess what? You don't have to connect it to the grid to charge your car. We're going to have free electricity, free charging. I'm only wondering, and I'll put a question to the accountants, how are they going to tax this? How's the government going to tax it? We're going to have sun tax or something. Thanks for following.
There's no doubt it's a much better system. But that's energy. How are you going to charge them? Everyone say, oh yeah, but the grid's not getting any bigger. So, and especially if you've got all of these car dealerships or car repairs, they're going to have electric power points. Whether they've got them or not got them is a different matter, but they will need power points. And the power hub and the Innagator is absolutely perfect for that. Because it's super low losses, it's not wasting energy on cooling itself down and operating itself. It's very super duper efficient. So it makes a difference when you're actually going to spend money and look at your rate of return. And also, if you're using a public charger where you're going to charge for it, it's very, very important that you're going to maximize your efficiencies and maximize your rate of return so you make money back. But a great opportunity is car dealerships. Every car dealership in the country will need to use these things. And it's such a wide open mark. But another place, leisure parks. Leisure parks are generally remote. You got 15 amp on each of your caravans, or 20 amp, pretty low power. They'll ban you from plugging car chargers into it because it'll just fuse the system. Everyone's on that. They got enough energy. These are superb opportunities for PowerHubs because you can trickle charge the units slowly, slowly. You can put solar panels on the caravans themselves to give it a bit of an extra boost, go straight to the MPPTs. That's free electricity, don't forget. And in the summer, when these things are being used, you got free power. Use it. For goodness sake, use the free power. Panels are cheap. Solar panels have never been so cheap. They're less than 1% of what they were a few years ago. 1% of the cost is incredible. And that's why solar works now. That's why it's a benefit. But on those two examples, they are absolutely perfect for PowerHub, and they can boost your power. You don't need to go and spend millions and millions and millions on rewiring the place and hundreds of millions on putting new power stations in when the energy's there. It's just that they're at the wrong time. You know, maybe at 1 o'clock, 2 o'clock in the morning, these generators, they don't switch them off. Say, hey, Fred, let's turn the generator off. We're all going home now. And we'll start it up again at 6 o'clock. No, they run continuously 24/7. And that's why dynamic pricing also works. And that's why people like say Octopus and all that, they benefit because they offer the cheap electricity, because these power companies buy the electricity dynamically. They don't pay the high price. They'll pay low when it's low, high when it's high. It's on the market. And often you'll sell to us cheaper than, especially for domestic, you're paying less than sometimes the real cost, because the dynamic, but they're trying to discourage you from using it, and they're offering you incentives because they don't want you to use it then. Because if an electricity company is paying 35 pence, for argument's sake, for a kilowatt hour, and they're selling it to you for 25p, then they want to discourage you. So they'll give you all sorts of incentives to not to use it during those periods and to lower it down. But absolutely amazing opportunities for car dealerships, leisure parks. Are just two. You know, everywhere there's going to be cars, supermarkets, hotels, businesses, everywhere, because cars are power hungry. They are absolutely a huge amount of energy. I know with the new housing and that we're going to be abolishing gas, it's all going to be electric. But, you know, easy pickings will be, look at car dealerships, look at the leisure industry. We need to focus them. Car chargers are going in everywhere. They are the industry. They're the people we should be focused on. And they are the people we should be using the LK, because the LK is super easy to service and super easy for lots of things. That's very important. I'm going to get onto serviceability in a minute. I'm going to talk about Sunsynk Connect and Sunsynk Connect Pro. Well, we haven't got the Connect Pro yet operating on the LK range, but it's coming, and it will be coming. And the Connect Pro will be to optimize it using AI. So you will have your Power Hub, and it will be run, and it'll be optimized with our AI technology. It should be available, I would hope, within the next 6 months, maybe less. We have it now on the domestic, so it's available. We call it Sunsynk Connect Pro, and you can use it. We do it in conjunction with a company called Conductify, who have a lot of American patents on using the AI with charging algorithms. It's an American South African company. Fantastic. But the one thing about it is we've also got the Sunsynk Connect, and that's giving you the web portal. And if you've got your systems, if you've got 10 PowerHubs, you join them together, you see it as one. If you're a car dealership and you've got 50 car dealerships and you want to see your energy in one, you can do. You can using our system. Our Sunsynk Connect is really, really good. We've got examples of where these systems are being used in factories. I saw one recently on eFix TV, and they actually had a factory, and the guy's got our Sunsynk Connect on the wall. He's got a big TV screen. You can see what he's generating, what he's not generating, everything he's using. And it's saving him, I think on that particular example, using the Sunsynk system, it's saving him £100,000 a year. It's incredible, the payback, especially using in conjunction with solar panels, because solar panels, like I say, they're free, it's free energy. So it's something really worth considering it. But our system runs, if you parallel, if you put one on, if you put more on, you just add them onto the Sunsynk Connect. The Sunsynk Connect will give you the information you need and the control that you need. And as I mentioned earlier on, the systems run locally on the local EMS. The cloud-based runs on the Sunsynk Connect. It's a system we've had for a long time. We've been improving it. We've got the security. It's hosted in Europe. It's not hosted anywhere else outside of the EU. It is a good system. It's solid. There are hundreds and hundreds of thousands of users of the system already. There's a lot of users, and it's going from strength to strength. decide if you're going to using the LK range, it works straight onto the Sunsynk Connect. It's something that people are familiar with, and it works. It does work. And people might argue differently. And we say that, but I can tell you, we haven't had any problems or outages for a long time now. It is superb. Very soon, when the Sunsynk Connect Pro comes with the AI, it's going to be a game changer. It's something revolutionary. So I'm almost getting to the end of the training. And I'm going to say one thing. If you choose any system, and I know people who are selling PowerHubs and containers type batteries who haven't a clue. These guys have not a clue. I know guys who are actually, they sell jeans or they sell whatever's the flavor of the day, they'll sell it. No doubt they will sell it. And they'll ask the factory, and if there's a problem, they'll call the factory, can you have support? That's all well and good for a short while. But if you haven't got your boots on the ground and you're not there and you haven't got your engineers around, you're going to be in trouble. You might think it's a quick buck. Well, I can get it 20,000 cheaper now. And it's suddenly got this device that's got plumbed in, it's got pipes everywhere, and it's got super high density, and they've got a serviceability problem because they need to service it because things go wrong. You're not going to buy a car really with the bonnet welded shut, because even an EV will have issues from time to time. And they do everything time to time. Maybe 99% of the time it's super duper reliable. But it's that 1% when it matters, and the 1% when you're going to have a problem and something falls down. And the nice thing about the LK, and what I've been going right through, it's a modular system. It's modular. So there's only 3 modules. You've only got 3 modules. You've got a power control system. You've got an MPPT, which is a tracker, and you've got an STS. And then everything else is just in a rack and controlled by HMI. That's it. There's 3 major modules. There's 3 components. Oh, and your batteries. There's nothing else to it. It's so simple. It's so simple. And that is the beauty of the LK range. And that's why we called it Life's Cool, because it really is cool. And people say, oh, yeah, but there's this system, there's this system, there's this system. But there's nothing so cool as what we've got. And the way it comes together with the Sunsynk Connect, the local EMS, the cooling methods, it is fantastic. It really is good. And we should be looking to get these tenders everywhere and quoting for these things, because it is good. We will put, in fact, it is on the book, there is an attachment to a QR code to a form. If you're interested in one, and I'll put the link up soon. If you're interested in one, you can get the link and you can fill the form in and say what you want it to do, and we'll get a quotation for it straight away. We really, really believe in our technology. It's there, and our technology is good. We are, many people, I go on about it, and especially now there's this boom in things, and you've got all these companies who never been in the business before. They do all sorts of wonderful things, but we live, eat, drink this technology. I'm nothing special. I'm an electrical engineer, as everybody knows. But I love it. I love the technology. Absolutely love it. We totally embrace it. So, next time you're thinking about, you have a project and you want somebody to work alongside you and give you the right support, the right product. Well, with a company that says, no power, no problem. And even if it's raining, please follow us and look at some of these training videos on YouTube and Facebook. Love to hear from you. So if you're there and we're ready to rock and roll, then please follow us. I've included on this document here a little bit about the pricing, but I think on the video I'm going to exclude the pricing. But if you look at the book, we've got something about pricing and the savings that you can make. It's all about savings. It's all about rate of return and making money, because the Sunsynk LK range is an amazing piece of kit. Absolutely superb. You won't go wrong. Thanks for watching the video. Thanks for doing the training. I hope it's useful. I've tried to keep it to about an hour. There's a lot in there. There's a lot to digest. If you're just listening to a podcast or whatever, then it's also worth listening to. Thanks for following us. Okay, thank you. And guess what? It is still raining. Look at this. Beautiful day, it's not raining. Another PowerHubs on its way. We have more in stock, we'll be able to sell more. Great product.
Sunsynk has the solution. Choose smart energy.